Welcome to the CS 320 lecture on Kleene's theorem. Now, this is part C of Kleene's theorem. We've already done the first part where we prove that transition graphs can get turned into regular expressions. And we've already started working on this, and we proved part 3 of this rule, 7b. And part 3 is that we can union any two regular expressions together or any two finite automatas together. So in this lecture, we're going to work on part 2 that says that we can concatenate any two finite automatas together. So as you're building a regular expression, if you concatenate two regular expressions together, you can also take the finite automata that accepts this language and the finite automata that accepts this language, and you can concatenate those two finite automata together to create a finite automata that accepts the result of concatenating both of those together. So let's go ahead and get started by an example. So what we're going to do is we're going to take any two, now this can work for any two finite automata, and you can read about the step-by-step procedure in the book. I'm just going to do an example of how you'll actually do this. So we're going to take this finite automata and concatenate it to this one. Now just so you know, this finite automata accepts all words that have a double A in it. If we read two A's in a row, then we land in the final state. And this is a regular expression that accepts all words with, or that defines the language of all words that have two A's in it. Now this one over here is all words that end in a B. As long as we read the rest of the word, then we'll end up in that state. And here is a regular expression. So we could create a more complicated regular expression by combining these two together, or concatenating them together. We want to do the same thing for these two finite automata. Now we're going to start by taking the start state of the first finite automata and just making a copy or writing it down. We're creating a new machine, and then we'll kind of do the same procedure that we did for the last part. If we're in state x1 and I read a B, I go back to state x1. So we'll just put that edge in here. And if I'm in state x1 and I read an A, I go to state x2. Okay, now if I'm in state x2 and I read at B, we'll go back to state x1. And if I'm in state x2 and I read an A, I go to state x3. Now this is where the procedure changes a little bit because we have a choice here. We could keep reading letters that belong to the first half of the word, or we can switch and start reading letters that belong to the second part of the word, or a word from this language. So in order for a finite automata to do that, we can't just magically transition to the other machine. We have to kind of pretend like, well, maybe I could be in one of these states or one of these states. So whenever you land in a final state of the first finite automata, you pretend like you're also in the start state of the second finite automata. So I'm going to put state y1 there. Okay. And now we still kind of use the same procedure. If I'm in state x3 and I get an A, I stay in state x3. And if I'm in state y1 and I get an A, I stay in state y1. So that one's pretty easy. Now there is one more thing that I need to add. Since I'm in state x3, since I read an A and I go back to x3, that also means that I have to be in state y1. But that one's already there, and we'll see more examples of that as we continue. Now, if I'm in state x3 and I read a B, I stay in state x3. And if I'm in state y1 and I read a B, I go to y2. Now, there's one more thing. Because I'm in state x3 and x3 happens to be a final state on my first machine, I can also transition and be in state y1 at the same time. So I have to include y1 in my list of things. So something that's different than what we did in the last lecture is, in the last lecture, you always had just you always had two states that you were in. In this case, we might just have one state, from the first half of the machine, or one state from the first half of the machine and multiple states from the second half of the machine. But don't worry, there's still just a finite number of states. We won't keep going on and on forever. So now we got an A and B edge coming out of this one, so now we need to work on this one. If I'm in state x3 and I read an A, I go to state x3. Because x3 is a final state, I also will be in state y1. If I'm in state x or y1 and I read an A, I stay in state y1, so that's already there. If I'm in state y2 and I read an A, then I go back to state y1. So that's all that we're left. Notice I did it for x3, y1, y2. x3 reads an A, it goes to x3. y1 reads an A and it goes to y1. y2 reads an A and it goes to state y1. And we're just left with these two, and we already have a state like that. So we can just draw an arrow back and put our A right there. Now let's continue and do a B edge. If I'm in state x3 and I read a B, I go back to state x3. If I'm in state y1 and I read a B, I go to state y2. If I'm in state y2 and I read a B, I go back to state y2. Okay, and then I forgot, because x3 is a final state of the first machine, I also have to be able to be in state y1. And we already have a state of x3, y1, and y2. Now the order doesn't matter, but we have these three states here, and that is back to itself. Now we have finished. We have an A exit and a B exit out of every state possible. So we've finished all of this, and this is now our new finite automata. There's still one more step though. Remember, to concatenate these two together, we need a word from this language and then a word from this language. So only when we're in the final state of the second one do we accept. That means we read one word from this language and then another word from this language and landed in the final state. So the only final state that we would include is the states that contain y2 inside of it. And that is just this state right here. Now this actually didn't make a bad finite automata for the concatenation of these two languages together. All words that have a double A in them and then end with a B. And this, if you were to create a finite automata yourself, you probably would create one that looked exactly like that. However, that's not the case for all of the examples that you might work on. Some of them will be pretty nice, like this one. Others might make a really long finite automata with quite a bit of states, but we're guaranteed to finish because we have a finite number of states in this finite automata and a finite number of states in this one, and we can only pair up each state with this one with each possible combination of states in the second one. So it is a large number of states, but it is finite. So we will finish creating a finite automata. We won't just keep creating new and new states and never finish. So that's the procedure on how we can concatenate any two finite automata together. So you get to practice this more in your homework.